Thank you so much for joining this lesson. We shall continue with the Alliance Mathematics Forum examinations, Mathematics Paper 1. And in this session, we are going to the section 2 of this paper. So I hope we shall cooperate through the 8 questions in section 2, which are very good, well thought out paper. So let's go through each question bit by bit. And it's my hope that learners are going to really benefit from this program. Remember to subscribe, remember to share so that you may invite a friend. We are also inviting you to our August programs, whereby students are going to register for a very serious program via Google Meet. So we shall have classes here for the sciences, mathematics, and also for the languages. We have made efforts to get the best tutors around the country. Therefore, enrolling to these programs shall be of great help to your student. So kindly welcome, invite a friend so that they may also enroll to the same. Remember to purchase your airtime from our platform, whereby you just go to the M-Pesa, Lipa na M-Pesa option. The pay bill number is 737356, and the account number is the phone number that you're purchasing the airtime for. So follow the simple procedure and get yourself sorted in terms of airtime. Airtel, Telcom, Safaricom, any line, any network that works in Kenya can purchase airtime. Thank you so much for your cooperation. Let's now get to the paper. We are told in number 17. Remember, a student here should choose the best 5 questions according to themselves. But in this program, we shall explore all the questions in section 2. Then now it's upon you in an examination to weigh yourself and see which one is better for me. Which one will I manage 9 over 10, 10 over 10, 6 over 6? So that now from that assessment, you can yourself choose the best for yourself. So let's check every question and see what exactly was required for each. A hotel bought a number of chicken at 1,200 Kenya shillings each and a number of goats at 15,000 Kenya shillings each. They paid a total amount of 135,000 Kenya shillings. If they had bought twice as many chicken and 3 goats less, they would have saved 15,000 Kenya shillings. Find the number of each type of animal that they bought. So this is on simultaneous equations that are being formed from word problems. Sometimes you can be given simultaneous equations, a pair for you to solve, but in other cases you'll be given a word problem for you to relate and come up with a simultaneous equation, then end up solving them. So now look at this. We can let the number of chicken to be X. X chicken, then goats are Y. Now from this we can say each chicken, because they are X and each is being bought at 1,200, then they costed 1,200X, then plus 1,500 per goat, and the goats are Y. This brought a total of 135,000. Then now there is more instruction. If they had bought twice as many chicken, that means twice is 2x, right? So 2x, then we multiply the 2x by 1,200. That will give us 2,400x. So more information is saying that 2,400x plus, and 3 goats less. 3 goats less means 1,500 being multiplied by y minus 3. Now, they would have saved 1,500. That means instead of spending 135,000, they would have spent 120,000. That is the raw interpretation of this question. The first step, just interpreting the questions. Now, from this kind of an equation, we can do further simplification because solving the equations now as they are, it would be a bit hectic. So we can work with smaller values. And let me begin by simplifying the second equation. This is 2400 x plus 15,000, the value of y minus 45,000. This is equal to 120,000. Yeah, that way. So with this now we can take the 45,000 to the right-hand side, whereby now the same equation shall be 2400, sorry, x plus 150,000, the value of y, equals to, instead of 120, now we have 165,000. That way, 165,000. Now we have two equations. This remains the first one, and now we are having equation number 2, because they are talking about the same goods and with the same prices. Then we can solve simultaneously to get the values of x and the values of y. Look at equation 1. If I simplify by dividing through by 100, then the equation shall be 12x plus 150y equals to 135, okay, 1350. That is a simplified equation 1. And equation 2 shall be 24x plus 150y equals to, dividing through by 100, 1650. 1650, yeah, well divided. Now from this, because we have simplified the two, we can use what we call elimination method. I would prefer elimination because the reason as to why I prefer elimination for this particular case is because the coefficients of y are already the same. So when I start subtracting corresponding terms, 24 and 12 shall give us negative 12x, but 150 and 150 shall give us y. Then we can check 1350 and 1650. These ones are giving us 300. Actually, negative 300, yeah. Negative 300 that way. So now with this, we can divide through by 12, because 12, you see, it's a negative 12x and a negative 300, meaning that the negative shall simplify and the value of x shall be 300 over 12. This is giving us exactly 25. With 25 as the value of x, we can obtain the value of y. Consider equation 1, for instance. 12 by the value of x, equation 1 at this level. Remember, equation 1 can be applied at any level. So you can use the unsimplified equation 1 or the broken down equation 1. They shall take us to the same value of y, plus 150, the value of y, equals to 1350. So this is 150, the value of y, equals to, I'm directly taking 1350 minus 12 by 25, and this is giving us 1050. 1050. So what about the value of y now? I have to divide through by 150. This is giving me 7. Remember, 25, which is x, was the number of chicken bought. So chicken, we now explain that chicken are 25, and goods goats are 7 because they are the value of y. That's simple. The value of y. So that's how it is. Very simple and easy to understand. Remember, solution of simultaneous equations is in book 1 mathematics. So kindly make sure that you familiarize yourself with simultaneous equations with whatever method, because there are very many methods of solving the same. Look at part B. The hotel sold all the animals at a profit of 30% per chicken, 35% per goat. Determine the total profit that they realized. Okay. So this is again a very good question. Remember, when we say 30% per chicken, it means instead of selling a chicken at 1200, now they sold a chicken at 130% of 1200. This amount. And remember, how many chicken are here? The chicken are 25. Then we add, okay, determine the total profit they realized. I think we are having several opinions here. Let's first approach it this way and say there is 135%. That means the selling price of a goat will be 135. We multiply by 15,000. Then how many goats are here? 7 of them. So from this, we shall realize the total selling price. The total selling price. So I will multiply 130 times 12. Then I multiply by 25. So I'm getting 39,000 from the sale of chicken. Then for the goats, 135 by 150 by 7. And I'm getting 141, 750 from the sale of goods. That means the total selling price shall be 180,750. That means now the exact profit can be gotten from, they spent 135,000 to purchase, but now they are selling at 180,750. So I will take the selling price and I subtract the buying price of all the items. So for this hotel, the profit realized now can be calculated. And this is 45,750. 45,750 Kenya dollars. So that is the profit realized. Alternatively, let's look at alternatively. What is the profit from a good? So this is alternative working. Alternatively, the same can be worked out this way. Profit per chicken. This shall be 30% of 1200. So for every chicken, this hotel realized a profit of 360. Profit per goat. This hotel realized 35% profit. So 35% of the 15,000 they bought a goat at. So this is 5,000 250 per goat. So total profit shall be 360 times the 25 chicken. Then we add 5250 times the 7 goats bought. So let's check now. This is exactly 45,000. Look at this, 45,750. So we are arriving at the same answer, the same answer. Well, part C. Again, a simple question. Let's try to understand it together. Ladies and gentlemen, remember to subscribe to our platform. Shifting Grades is the best for your tutorials. Remember, if you would like to pass in mathematics, physics, just be a follower of Shifting Grades. Remember, our programs are very serious. Remember to follow up with our weekend contests. We usually upload contests actually every weekend. This one we usually do via WhatsApp. So we can just WhatsApp my line 0704 at WhatsApp 153366. Through this number, you will be able to see my status updates. That way, you'll be in a position to take part in our weekly contests. We only share one question, which is a bit challenging, I would say that. Then the best student or the student who does it correct and very quickly gets the award. So even if you're very correct and you're submitting your answer when somebody else has submitted and is correct or she is correct, then you don't stand a chance. So we award the one who does it very quickly. So please just enroll to our programs. They are very many and very rich. Please reach out for more. Reach out for more. If they had bought twice as many chicken and 3 goats less and still sell at profit of 30% per chicken and 35% per goat, determine how much they would have gained or lost from the deal. How much they would have gained or lost from the deal. So in this case now, the chicken are going to be the chicken are going to be twice. So we are now selling. Remember, we have realized in the question above that profit per chicken is 360. So 360 times 50 chicken. That is the profit. Then profit from goats, 3 goats less. When you talk about 3 goats less, then it means the profit of 5250 shall be multiplied by 4 goats instead of 7 goats. Yeah, 4 goats instead of 7 goats. So what profit shall we have here? 360 times 50. I'm getting 1800 here. 18,000 plus 5250 by 4. 21,000 that way. So 21 plus 18. This is 39,000 profit. So this is the profit that they would have realized. This is the new profit they would have realized. But remember, the original profit from the deal is 45,750. So the new profit is 39,000. Do you think they would have lost from the deal? Yeah. So they would have lost 67.50 compared to the original deal. So we have just related the first deal, which would have brought 45,750, with this new deal now, which is bringing a profit of 39,000. So through such a deal, it is still a profit, but the hotel has benefited less. I don't know whether you get that logic now. The hotel has benefited less. Number 18 from geometry. Using a ruler and a pair of compasses only, construct a rhombus PQRS in which the angle PQS equals to 30 degrees and the length QS equals to 7 centimeters. Something that you're supposed to understand about a rhombus. About a rhombus is that in a rhombus, it's just a twisted square. In a twisted square, it means that all sides are equal and also opposite angles are equal. Something else that you're supposed to know about a rhombus is that the diagonals of a rhombus meet at right angles. So let's look at, that's why we've been given only one side, which is the length QS. The length QS is 7 centimeters. So let's look at that. Let's just look at that. 7 centimeters. So I'm first going to construct the angle. I'm first going to construct the angle at PQ. So the first thing that we're doing here is the angle at PQ, which is 30 degrees. So let me start by a straight line. Then the first thing I'm labeling is Q. This is Q. So while at Q, remember P is on the same line, we are supposed to construct 60 degrees because we're going to use a pair of compasses and a ruler only. We are not supposed to measure angles using a protractor. Yeah, we're not supposed to measure angles using a protractor. Therefore, allow me now to construct the angle PQS. The angle PQS. Or can I begin with a sketch for people to understand? We have a rhombus like this. This rhombus is having equal sides. This is P, Q, R, S, that way. So the angle provided, when we talk about PQ, when we talk about PQS, we mean the bisected angle here. That is the one which is 30 degrees, which means the angle now for the diagram itself, for the rhombus, is going to be 60 degrees. So PQR is 60 degrees. PQR, 60 degrees. Yeah, 60 degrees. Therefore, the first thing that we shall do, let's just construct the 60 degrees first. We just construct 60 degrees. So what we are doing here is, first of all, we construct 60 is trying to get my compass very well so that I construct a very perfect 60. But remember, from the screen, we just do estimations. Like at this point now, I'm supposed to just stand at Q and I make an arc. Then while on this arc at the line, I cut the first arc. Through that, I'll be in a position to join now the arc and Q for me to get what? Exactly 60 degrees. Then I prolong that. This is 60 degrees. But now, if I bisect this angle, I'll be able to get now the 30 degrees that we are talking about for PQ to S. So 30 degrees I bisect. So I stand at this arc, I make an arc, and standing on the other side, I also cut the first arc for me to bisect the angle. So through this, I'll have bisected these. So when I produce an angle like that, or yeah, that way, this is the 30 degrees now. Let's get back to the instructions. You should be able to realize that PQS now is 30 degrees, already realized. And from Q to S, not Q to R. Remember, Q to R is the line here. Q to R is already on the sketch. That is not the 7 centimeters. We are measuring 7 centimeters from now Q through the angle of 30. 7 centimeters, the angle of 30. So this is where my 7 centimeters is. So standing at this point now, I'm just supposed to finish everything. Like, I should just do a line which is parallel to the base. Parallel to the base. And one thing that we realized is that, this has become our point S. So one thing we should realize is that being a parallelogram, the baseline and the top line should be the same. Therefore, now I'm supposed to just produce a line which is very parallel to the base PQ. So now from this point, I am supposed to mark a very parallel line to the base. Therefore, allow me now construct another 30 degrees. Yeah, I construct another 30 degrees. Therefore, for me to construct a 30 degrees angle, I'm supposed to, standing at S. Remember, I'm not supposed to measure. So I stand at S and I make an arc so that I be in a position to construct another 60. Then it is the 60 to be bisected. It is the 60 to be bisected. Therefore, I stand there, I make an arc. Then while on this arc, I cut like that. Then now, if I bisect this now, remember this is automatically 60. If I bisect this angle, I will be in a position to come up with 30 degrees. Therefore, I stand on the first arc, I make an arc. Standing on the second, I make another arc, like that. So when I produce a line through that, it shall be parallel to the base, and through that, I will be able to realize my point R. Therefore, point R is here. That is from bisecting another 60 from S, because all the lines are supposed to be parallel, and furthermore, they are supposed to be equal. Then now I am supposed to pick the radius from R to S. Then I stand at S and I mark it off on the base, or I just stand at Q using that measurement. The measurement of, remember I'm using a compass to lift the distance from SR, and I transfer it to the base. I transfer it to the base. So when I transfer this to the base, I'll mark off at this point. I'll mark off there. Then when I drop now, this is very interesting that according to my approach, P is the last to be identified. So that is my P. Okay, they allocated 5 marks for that, but it's good for you to know that it's a very simple working. Very simple working. So that's how you are supposed to construct the rhombus. There are easier methods. Please just explore, just explore. The methods are several on how you can come up with a rhombus like that one. From this, there are more instructions that are saying you drop a perpendicular from S to meet QP at N. So QP should be produced so that we can drop a perpendicular from SN. So standing at S, we are supposed to drop a perpendicular to a given line, QP. So I stand at this and I make arcs like that. Then standing on those arcs now, I can make other arcs above. So standing here, I make an arc and I cut the first one, such that I'll be in a position now to drop a perpendicular. This is a perpendicular, meet at N. So now we are advised to measure SN, which is exactly 6.6. SN equals to 6.6 centimeters, that one. 6.6 centimeters, yeah? 6.6 centimeters. So that one is done. Then now, more instructions are telling us to measure PQ. Measure the length of PQ. Then from that, from that, we are supposed to calculate the area of the rhombus. Remember, PQ is exactly 4 centimeters. PQ is 4 centimeters, and any other length, 4 centimeters. Therefore, we shall calculate the area of a rhombus, which is simple. Area of a rhombus equals to base times height. Therefore, this is 4 times 6.6. Let's check the final answer. 4 times 6.6. This is 26.4 centimeters squared. Remember, this can have several other options, alternative, or there is a range for this whereby this length should be measured with an accuracy of 0.1. So a student with the height of 6.5 is correct. A student with 6.7 is also correct. So there are those options for the height. Then for the base, this is the height. Now for the base, which is 4, there is also an accuracy of 0.1. And that means a student with 4.1 is correct. A student with 3.9 is also considered to be within the correct range. So any product here now will also be treated to be correct. Any product will be treated to be correct. So it can be 4.1 and 6.6, or 4.1 and 6.5, or 6.7. There are very many options. So at such a stage, in such a stage, the teacher will automatically follow through the student's work and mark their different accuracies. But make sure whenever you're doing geometry work, you're very accurate to ensure that you don't miss some of the questions out of negligence. Make sure that you are very accurate. In case you're not very accurate, just remain within the range. Make a reasonable error, in other words. You see now number 19? Hello. This one is in the figure below represents a model of a solid structure in the shape of a frustum of a cone and with a hemispherical top. The diameter of the hemispherical part is 70, as you can see, and is equal to the diameter of the top of a frustum. Then the frustum has a base diameter of 42 centimeters and a slant height of 60 centimeters. Look at the first part of this question. I hope we can all understand the diagram. It has been drawn well in 3 dimensions. Calculate the surface area of the solid. This is a solid. Therefore, we need to check all the faces making it. Therefore, just look at all the faces making it, and you realize that there is an hemispherical top. We are also having a conical part, though it is a frustum. Then we have a base, which is circular. So we must take care of the 3 faces that are appearing. So the first thing that you shall do is to use similarities and enlargements to work out the original dimensions of the cone from which the frustum was obtained. Yeah, from which the frustum was obtained. So let's work out that first. So we want to assume that there is a small slanting height of L, which was cut off here. So you see there is an original cone from which the frustum was obtained. So we usually relate in this manner by saying, when we take the diameters, diameter of original cone is 70. When we divide it by the diameter of the smaller cone of 42, we are supposed to get the same ratio as when we relate the slanting heights. So original slanting height, 60, plus a small L, which was cut off, divide by the small L that was cut off. So you see, we cross multiply to have 70L is equal to 60 by 42, which is 2520, plus 42L that way. So 70 minus 42 equals to 28. L equals to 2520. So the value of L shall be 2520 over 28. 2520 divided by 28. This is exactly 90 centimeters. And this means the original slanting height now is supposed to be 70 and 90 added. No, 60, sorry. 60 and 90. Yeah, 150 centimeters. So we have now the dimensions. We have the dimensions now. So with this, we can now talk about surface areas now. We can talk about surface area. For an hemisphere, let's start with hemisphere. So for an hemisphere, we talk about 2 pi r squared. Remember, the full sphere would have been 4 pi r squared. So 2 pi r squared, 2 by the value of pi. They have not instructed us to use any pi, but we can choose 22 over 7 times a radius of The top radius is 35. So this 35 should be squared. So from the hemisphere, we shall have 2 by 22 over 7 by 35 squared. This is giving me 7700 square centimeters. Then from the hemisphere, we can talk about the bottom circle. The bottom circle, pi r squared, area of a circle. The radius is 21 there, squared. So 22 over 7 by 21 squared. On the base, I'm getting square centimeters, 1386. Now that we are having the base circle, we need now to go to the slanting height, or rather the curved part of this particular solid. So we need to talk about area of the original cone, curved surface area of original cone. So for us to get the frustum part, for the frustum, we will need, remember area is pi RL. So we subtract pi RL for the smaller cone. So with this, we can talk about pi R L, slanting height of 150. Yeah, slanting height of 150. Pi RL. Pi RL. Then we subtract pi R of 21 and a slanting height of 90. Yeah, slanting height, the small l of 90 and the small r of 21 now. So from this, we shall get the curved of the frustum part. 22. Actually, we can open brackets so that we do it once. 22 over 7 multiplied by 35 multiplied by 150. That is for the original, minus 22 over 7 multiplied by 21 multiplied by 90. This shall be 10,560. Square centimeters. And with this now, we can talk about total surface area. 10,560 frustum, 1386 the circular base, then the top hemisphere 7700. So let me talk about the total now. We add 1386 and we also add 7700. This is 19,646 square centimeters. Yeah, 646 square centimeters. So that is it. That is how we are supposed to work it out. Very simple. Very simple. Let's check now something else here. Part B. You know, we used the space for part B, but at least you have understood part A. We had to prolong the diagram for you to see the smaller cone which was cut, the original cone, and the frustum that remained. So with this now, can check our part B. Let me try to manage the space on this side. We need the volume of the whole solid. For us to get the volume of the whole solid, we need again to take the volume of the shapes involved. So now what shapes are involved here. A top, which is hemispherical. And remember, for a sphere, we use 4 over 3 pi r cubed. So being hemispherical, it is 2/3 pi r cubed. So we need a hemisphere. The hemisphere it shall be 2 over 3 pi r cubed that way. So 2 over 3 pi. The radius is remember the top diameter is 70. So we talk about 35. It is now 35 that shall be cubed. So from the hemispherical part, let's get it. From the hemisphere, 2 over 3 by 22 over 7 by 35 cubed. This is exactly 89, 833 and a third cubic centimeters. Yeah, and a third cubic centimeters. Now we talk about the other part. Remember volume, this part B. Remember volume of the hemispherical part has been obtained. What about the frustum part? We need volume of original cone minus volume of the smaller cone that was cut off, right? So now let's again manage the diagram. In having a slanting height of 150, but we don't know the vertical height. We know not the vertical height. So we shall use Pythagoras theorem to get the vertical heights. We have 150 and a radius of 35, another radius of 21. So I shall talk about 150 squared minus 35 squared, the square root. So let's get this first. 150 squared minus 35 squared, the square root, 145.86 centimeters. This one now is the height of the original cone. Then for the smaller cone, we shall use 90 squared minus 21 squared. Then we take the square root. So the small height for the cone, which was cut off, shall be, I'm using the 90 here and the 21 for the smaller height for me to get now, for the smaller radius, for me to get the height. So 90 squared minus 21 squared, then I carry out the square root, I'm getting 87.52 that way, centimeters. So at this point now, I'll be talking about volume of the frustum. And you know, for the frustum, we need original cone minus smaller cone. So a third base area, so pi r squared times h minus a third pi r squared small h. So I'm using a third pi, a radius of 35 squared, and an original height of 140 what? 145.86. 145.86. Then I shall subtract a third pi, then a radius of 87.52, a radius of 21, sorry. Then the vertical height, 87.52. So let me get these specific values. A third by pi times 35 squared times 145.86. This is a 187 minus Yeah, it's my hope that I have multiplied it right because I'm using a third. Let me just repeat that. Times 22. It's like I didn't expect a whole number to feature. 35 squared times 145.86. Exactly 187, 187. Then minus a third, 22 over 7, 21 squared times 87.52. This is giving me 40,434.24. Then I have to subtract now. 187, 187. Then I subtract this value to give me 146,752.76 cubic centimeters. So I have now the two areas, the two volumes which are supposed to be added. So total volume shall be total volume. This shall be, I get 146,752.76, and I add for the hemisphere 89,833, 89,833 and a third. So we add 89,833 and a third. This is giving us 236,586.0933 cubic centimeters. So that is now the exact, that is the exact volume. Remember, because of rounding off, we might get variant answers. Like the heights that we've just calculated, they've been rounded off to two decimal places. Generally, we are working with 2 decimal places here because with 2 decimal places, the answers are already more than 4 significant figures. So I hope that one is understood. There's also the difference in the pi used. Somebody can work out the same question using 3.142 as the pi, or the value of pi in the calculator, ending up with slightly different figures. But that is how the concepts should be applied. Look at number 20 from equations of straight lines. Two lines, L1, 2y minus 3x equals to 6, and L2, 3y plus x minus 20 equals to 0 intersect at point R. Find the coordinates of R. The point of intersection of L1 and L2. This is when we solve the two equations simultaneously. Then we shall get x and y. From equation 2, x equals to 20 minus 3y. I've just rearranged this equation to remain with x. 20 becomes positive, then minus 3y. So equation 1 can be rewritten as 2y minus 3, and instead of x, 20 minus 3y. This is equal to 6. 2y minus 60 minus 9y minus 9y equals to 6. I hope, the opening of brackets is clear. You see, I'm having 6. I'm having is this 6? What point am I having here? I want to group the terms very carefully for me not to confuse anything. I should have multiplied to get a positive on this part. I think that is what I wanted to clarify, because of negative 3 by 6, negative 3 by 20, that is 60, and it's a negative. But negative 3 by negative 3 becomes positive 9, that way. So you're supposed to be very keen when opening brackets so that you don't make slight mistakes. 11y equals to 66. The value of y, 6. Let's find x. x is 20 minus 3 into y. So 20 minus 18, which is 2. That is the value x. That's the value of x. Now that we have the values of x and y, then the coordinate of r can be expressed as 2, 6. You must give it as a coordinate. Remember that. You can't leave the answer as x and y separately. That way, you make it a coordinate, r. Then we proceed now with solving this. Look at part B. Another line L3 is perpendicular to L1 at R, the R that we've calculated. Find the equation of L3 in the form y equals to mx plus c, perpendicular lines. So let's arrange equation 1 first. Equation 1 shall be 2y minus 3x. So 2y, the 3x becomes positive here. And there is already a 6 on that side. So y equals to 3 over 2x plus 3. This is the equation of L1. We want to find equation for L3. So what we're supposed to do in this case is to say that L1 is having a gradient of 3 over 2. Then there is L3, which is having gradient M3. This gradient should be such, you know, the two lines are perpendicular to one another. So when lines are perpendicular to one another, ladies and gentlemen, the product of their gradients is always -1. So which number should be multiplied by the number we are having? Which gradient should be multiplied by 3 over 2 to give us a -1? And I want to make your work simple. Don't be overworking at this point. The second gradient for perpendicular line is usually the reciprocal with the opposite sign. Reciprocal of 3 over 2 is 2 over 3. But now we are saying with a minus. So these two gradients now, their product shall be -1, proving that the two lines are perpendicular. So now that we are having the gradient for line 3, and we also have a point where it passes, that is a point R, then we can express the equation. Because point R is 2, 6. So we need to use point R and another coordinate, xy. So -2 over 3 equals to y minus and x minus 2, because coordinate of R is 2, 6. So we use that. And another coordinate, xy. Then we express our gradient, y minus 6, that is the change in y, and x minus 2, the change in x. Across multiplication will give us 3y minus 18 equals to -2x positive 4. 3y equals to -2x plus, is it 22? Yeah, 4 plus 18, I think 22. So from this now, we can fully rearrange our equation to remain with y alone by having -2 over 3x plus 22 over 3. We can give it as, just give it as a mixed number, 7 and a third. 7 and a third, that's it. I've divided through by digit 3. So that is the equation in the format that we needed it to be. Very simple. Now we can talk about the last part of this. The last part of this. Part C. Another line, L4, is parallel to L2 and passes through -1, 3. Find the x and y intercepts of L4. So let's have L2, line 2's equation organized. Line 2's equation is here. 3y x minus 20. So 3y plus x minus 20 equals to 0. 3y equals to -x plus 20. So to remain with y, we have -1/3 x plus 20 over 3. For this particular L2, we can say that the first gradient equals to negative a third. Then what about gradient 4? The lines are parallel to one another. The lines are parallel to one another. Now that they are parallel to one another, we are supposed to understand that for parallel lines, gradients are usually the same. So this other gradient is also negative a third. The other gradient is also negative a third. Negative a third. That way. Okay, now at this step, ladies and gentlemen, at this particular step, you will allow me now talk about the equation now. Yeah, I think we need the equation now because the line 4 passes through negative 1, 3. We can use negative 1, 3, and another coordinate xy for us to express the gradient. After expressing the gradient, we shall be in a position now. We shall be in a position to talk about the x-intercepts and also the y-intercepts. So, negative a third. I don't know whether you've subscribed to this program. I don't know whether you are a subscribed member of Shifting Grades. Kindly do so. If yet to, just remember to subscribe to this platform so that we keep growing. Change in y, y minus 3. Change in x, x minus a negative 1. So we cross multiply 3 goes with y minus 3. The negative 1 goes with x plus 1. Plus 1 because of a reason that you know, x minus a negative. So from this, we are talking of 3y minus 9 equals to negative x minus 1. That way. 3y equals to negative x plus 8. I hope that is clear. I hope the plus 8 is well understood. Yeah. Okay, at that point or at a different point of this equation, we can now start talking about the intercepts. What is the y-intercept? Y-intercept is the point where the line cuts the y-axis. And at that particular intercept, the value of x is usually 0 because it's along the x-axis. It's along the y-axis. All values of x are 0. So when we substitute x with 0, we shall get the y-intercept. 3y equals to negative 0 plus 8. 3y equals to 8. The value of y shall be 8 over 3, which is 2 and 2/3. That is the y-intercept. What about the x-intercept? The x-intercept is the point along this line when the line cuts the x-axis. And at that point, values of y are usually 0. If the value of y is 0, then we can say that 3 into 0 equals to negative x plus 8. So that x can be positive here. We get 8. So the x-intercept equals to 8. The y-intercept, 2 and a third. Remember, when this equation is at this final stage of y equals to negative a third plus 8 over 3, the y-intercept can be extracted automatically here. This x, sorry. Negative a third x plus 8 over 3. The y-intercept can be read as the constant there. So with an equation in the form y equals to mx plus c, the c is usually the y-intercept. The c is usually the y-intercept. That way. Look at number 21. The table below shows marks obtained by 40 from 4 students of Majinyingi Secondary School in Ukwala Township in mathematics and term examination. The marks are there, distributed in classes. Then we have the frequencies. Look at part A. State the model class. The model class is the class with the highest frequency. That one should be understood. The class with the highest frequency. Therefore, from this, we can assess the values of the frequencies. And I can see that the highest frequency is a 14. So which is that particular class? 50 to 60. So that is the class which we can call the model class. It has the highest frequency. Then from there, we can now talk about the mean. Can talk about the mean. $50 to $60 that way. Let's talk about the mean, whereby we need the midpoints first. So midpoint is usually abbreviated X, midpoint X. We need the upper limit, lower limit. We add them, then we divide by 2. Then we divide by 2. So let me manipulate the data up there. We're just extending the columns a little bit. Just extending the columns a little bit. Yeah, let's check. Let's check whether we need all these columns. Anyway, the values of X. Remember the values of X, which are the midpoints, are purposely calculated to ensure that each class is represented by its own midpoint. In this sense, listen well, in this sense, that if we are having 20 to 30 and there are 2 students there, according to the frequency, when we take 20 plus 30 and divide by 2, we shall get 25. So we assume in the fx now, we assume that the 2 students are all having 25. They are just between 20 and 30. Maybe they are at 29 or at 21, but we don't know. They just lie in that class. So we let the midpoint of a class represent everybody in that class. Then the next shall be 30 and 40 for 70 to give us 70. Then we divide it by 2, sorry. Yeah, the 70 should be divided by 2. 35. The next will be 90, 45, 110, 55, 130, 65, 150, 75. That way. So we have the values of X. So 2 by 25, we need f of X now. So all the marks in the first class are going to be 50. Then 35 by 4, 140. 6 by 45 to 70. 14 by 55. This gives us 770. 8 by 65. That gives us 520. 6 by 75. That gives us 450. You see now? So we are having all the values of f of x. Then now we can get total marks now. Remember, mean shall be given by the summation of f of x out of the summation of f. These are 40 students. So we need the summation of f of x now, 50 plus 140 plus 270 plus 770 plus 520 plus 450. Everything now should be divided by the 40 students. So this is going to be 2200 out of 40. The mean for this class is going to exactly be 55. Well, this is a very good class. Don't joke with 55 as a mean score in mathematics. Actually, in KCSE, this is more than B plus, or even a B plain. So this is a good mean. Anyway, that's how a mean should be calculated. Look at part C. Estimate the median of the data. Estimate the median of the data. We know very well that median is usually given by lower class boundary plus total frequency over 2 minus cumulative frequency just before the median class out of frequency of the median class multiplied by the class width. At this point, what we need to realize is what we call the median class. How do we get the median class? Let's get first of all cumulative frequencies. The first frequency is 2. We work them using some different ink. The first one is at 2. When we add 4, we're getting 6. When we add the next 6, we're getting 12. When we add the 14, we're getting 26, right? When we add 8, 24. And when we add I think we should be very careful here because the examiner talked about 40, right? By 40 from 4 students. 40 from 4 students. When we add up, are we getting 40? Or am I the one? Yeah, these are 64. These are 34 now. From 26, we get a 34. Then when we add 6, we get now 40. They are exactly 40. Yeah, very true. Exactly 40. Now with this, ladies and gentlemen, we shall take the total frequency of 40 and we divide it by 2 to give us 20. Remember, we just want to know the median class. So, because the total students are 40, then the middle student is the 20th student. According to the cumulative frequencies, where is the 20th learner or where is the 20th student accommodated? So the first cumulative frequencies are 2, 6, 12. So far, we don't have 20 yet. But with 26 now, it means the 20th learner is in that particular class. So this becomes our median class. The median class is the class 50 to 60. The class 50 to 60 is having the median. So we start with the lower boundary. There is something that I want you to notice with a lot of concern, that the data that we are having is what we call continuous data. In continuous data, unlike discrete data, the limits here are also the boundaries. For example, from 30 to 40, the other class also begins at 40 to 50, the other one begins at 50 to 60, like that. You'll discover that the upper limit of a class becomes the lower in the successive class. So that means we shall not work with the ordinary boundaries which are found in discrete data. Are we together there? You are supposed to understand that in a continuous data, the limits are also the boundaries. So when we talk about the lower boundary in this case, when the lower limit is 50, we shall still use 50. We shall not go to 49.5 because when you go to 49.5, you are inside the previous class. A value like 49.5 cannot be taken as the limit of this median class, cannot be treated as the boundary. Reason because 49.5 is a value already inside the other class. Therefore, we talk about 50 as the boundary. Then we add 40 over 2 minus the cumulative frequency just before this class. Just before the class, we have a 12. So we pick 12 just before. Then frequency for this particular class. Frequency for the median class, which is 14, and everything should be multiplied by the class width of 10. We know for us to get the class width, we need upper limit minus the lower limit, right? So that's a 10. Now we engage the calculator for us to get our final answer. So I'm having 20 minus 12, then I multiply by 10, then I divide by 14, then I add 50, and I'm getting 55.71. 55.71 is the median mark. 55.71 is the median mark. Remember to comment, remember to like, remember to share as we proceed to the statistical graphs. These are the main statistical graphs in mathematics paper 1. Remember, in mathematics paper 2, you expect an ogive, which is the only statistical graph in paper 2. In paper 1, histogram and frequency polygon are the main graphs which represent data there. There are other graphs like fear charts, bar graphs, and all that, but the main, and also pictograms, but the main statistical graphs are what we're going to deal with at this particular point. Aha. So we're going to first plot histograms to represent this data. And there is something that I have always advised my learners about histograms, more so when the histograms shall be plotted together with a frequency polygon. I will keep reminding learners. I'll just keep reminding you about very basic things in this. Remember, on the vertical axis, for you to get a frequency polygon, for you to get a histogram, sorry, you should be having frequency here. So that's where we shall plot our frequency. But here we shall have our class boundaries now. Class boundaries. The first boundary is at 20, or rather the first class, according to the provided marks, is 20 to 30. So I usually advise my learners to do this. It is good to begin with a class such that this class, you see, from 0 to 10, then 10 to 0, we begin with a class. Can actually break the axis like that. Then we start from 10 to 20, 20 to 30 to 40. Then we have 50, 60, 70, 80, 90, 100, like that. So look at the first class, 20 to 30, then 30 to 40. We usually supposed to imagine a class just before the first one, which is the class 10 to 20. Just begin with a class before this. And after 80, talk of a class 80 to 90. Talk of another class 80 to 90 after that. On the axis, just make sure you accommodate that. Just ensure you accommodate a class before the first provided one and a class after the last provided class, or more. A class or more. So we have the x-axis well labeled. This is where we have the marks, or rather the class boundaries. Then the frequencies are starting from, the least is 2, the highest is 14. So we can use intervals of 2. Intervals of 2. Yeah, so that we have 0, 2, 4, 6, 8, 10, 12, 14, 16, like that. The first class is from 20. Let me use some ink, which is blue. 20 to that, 20 to 30, then the frequency is 2. So the frequency is 2. So the first class should raise up to 2. Then we enclose the boundaries. Remember, the bars in histogram are supposed to be important, like that. Then we can talk about from 30 to 40 for students. So we are raising up to this point for students. That's why we cannot say that we are plotting against upper boundaries. Not upper boundaries, not lower boundaries. It is simply the boundaries. So it is the boundaries that shall enclose the whole bar to give us that way. Then we are having 6, 40 to 50 students there. 6 students. Then we have 14 for 50 to 60. 50 to 60, 14. That is the bar. The higher the frequency, the taller the bar. After 14, we can talk about 8. 8 students for next class. Yeah. Students. That way. Then we can talk about the last one, which is 6 students. 6 students. So look at my bars now. This is what we call a histogram when class intervals are the same. Remember, there is another interval. There is another type of a data whereby the classes are not equal in length. There we come up with frequency density. That is it. Now I want you to know this, that frequency against the boundaries, we get a histogram. But now the examiner is demanding a frequency polygon on the same axis. So you should know that the middle part of this bar, if it is between 20 and 30, the middle part is automatically giving the coordinate of the midpoint. Therefore, for us to get what we're calling a frequency polygon, we need frequencies against midpoints. So we have automatic midpoints here. Automatic midpoints against frequency. Just at the top middle of each bar. The top middle of each bar. Top middle of each bar shall automatically imply frequency against midpoint. So those are the automatic coordinates of frequency against midpoints. Then with this now, we can come up with a frequency polygon. You join automatically. From one midpoint, you use a very straight line to the next. A very straight line. It should be a straight line. Then again, another straight line. We use line segments. A straight line like that to the other midpoint. A straight line to the next midpoint. A straight line. So never use your free hand or use a curve. Ensure it is connected like that. So after this now, we shall talk about how do we support this frequency polygon. So you don't leave it hanging on the tops like that. You are supposed to anchor it. You anchor it at the mid of the class that you started with. The blank class that you started with, you drop it there. And also at the mid of the class, which is blank, but beyond the last bar, you also anchor it there at the mid. It should be on the axis now. So that is how the frequency polygon should be supported. That is how the frequency polygon should be supported. So now from this, we can say that the green line is our frequency polygon. This is our frequency polygon. Then the blue bars. The blue bars are our histogram. Yeah, that is now the histogram frequency polygon on the same axis. Very simple work, easy to understand. Please follow up with our programs. We are having very many plottings of statistical graphs. Don't be ignorant, kindly. Knowledge is available and it is free. Please access shifting grids for you to advance in mathematics. This number what? 22 now. Our next question, which is number 22. We're going to read it together. If you're following us, please remember to subscribe to Shifting Grids and also to share this platform with friends. Let your friends know about Shifting Grids. It is unfair to follow us and let your friends not to know about us. So kindly direct friends to Shifting Grids. Just tell them about how we are doing it here. Tell them to subscribe just like you, and it shall be well with you. So let's discuss these remaining questions very quickly now. Number 22, look at this. The average speed of KDS school bus was 20 kilometers per hour faster than the average speed of KBL school bus. KDS school bus took 45 minutes less than KBL school bus to cover a distance of 180. Part A, if the speed of KBL was X kilometers per hour, the Roman one of this, write an expression in terms of X for the time taken by KBL school bus and KDS school bus respectively to cover the distance of 180. An expression for time. How do we get time generally? Distance over the speed. Therefore, if we are talking about the time for the KBL, time for KBL, distance over X. What about time for KDS? You know, KDS was 20 faster. So it shall be 180 out of a speed of X plus 20. This time is in hours. So we have the two times now for the two buses. Then in part 2 of Roman 2 of part A, determine the speed of KBL bus and the KDS bus. Let us look at these now respective speeds. We are told that the bus which is faster, that is KDS, it took 45 minutes less. Remember 45 minutes, ladies and gentlemen, is the same as 3/4 of hours. So 3/4 of an hour. So that is the conversion that you need to be conversant with. So the time difference is 3/4. So the time taken by the first vehicle, which is KBL, 180 over X, minus the time taken by this other one, is just the same as 3/4. So this is what we should be having as the first equation according to the interpretation of this information. So with all this, we can now have the LCM of the denominators. So LCM divided by the first denominator. LCM divided by the first denominator should give us the X cancels. So it will be the numerator times 4X plus 80. Then minus LCM divided by the second denominator, whereby X plus 20 is the one to cancel now. So 180 here multiplies 4X equals to LCM divided by the last denominator, which is a 4. We shall have the 4 cancelling and have 3 multiplying by x squared plus 20x. That way. So now we can open up to get this, the equation itself now. Yeah, to get the equation itself. So to get the equation itself, ladies and gentlemen, I'm supposed to talk about 180 by 4, 720x. Then 180 by 80. I'm getting 14,400 minus 720x equals to 3x squared plus 60x. That way. At this stage, can we group some terms like 720x and 720x? That one will just automatically eliminate one another. So we can have this one as a quadratic equation now. 3x squared plus 60x. Then we subtract 14,400 to get a 0. To remain with x squared, we can divide through by 3. So this is 20x minus, when I divide this by 3, I'm getting 4800 equals to 0. So the quadratic equation has been simplified. Well simplified. So we can solve it using any of the methods of solving quadratic equations. We have factorization in Form 2, and I'm sure Form 2s are following up. So we can prefer the factorization method. Remember, there is the quadratic formula itself, and there is completing the square. So at this point now, we need a product of A times C to give us negative 4800, because the value of A is 1 and the constant C is negative 4800. Then sum the value at B, which is 20. So two factors, when multiplied, negative 4800, and when added 20, we shall talk about 80 and negative 60. Yeah, 80 and negative 60. When added, positive 20. When multiplied, negative 4800. So now with this, we can rewrite our quadratic equation. X squared, instead of plus 20, we can add 80 and subtract 60. X. Then minus 48 equals to 0 that way. So from the first two terms, we can factor out x. We remain with x plus 20. Then we factor out 60. So that will remain with x plus 80 again equals to 0. So from the brackets, we can get x plus 80 x minus 60 outside the brackets equals to 0. So from the first brackets, x equals to negative 80. From the second one, x equals to 60. With this, ladies and gentlemen, we would say that the speed of the first bus, if the speed of KBL is x, so KBL used a speed of 60 kilometers per hour, and the other bus, which was 20 kilometers per hour faster, KDS, now used 20 plus 60, 80. Excuse, kilometers per hour. Yeah, 80 kilometers per hour. 80 kilometers per hour. So it is already done. Very well calculated. That way. We can proceed to the part B of this. The distance between Alliance High and Maseno School is 460 kilometers. On a certain day, the KDS school bus started a trip from Alliance High at 8:30 a.m. and the KBL started from Maseno School at 9 a.m. Determine the time that the KBL school bus and KDS met. We're assuming that they are using the speeds above, right? Then now that they are approaching one another, these school buses are going to have a relative speed of the sum. So relative speed shall be 60 and 80 for 140 kilometers per hour. So the distance between Maseno School and Alliance High is being covered at a joint speed of 140. So the relative distance between them. Okay, that is the relative speed. And you see, the first bus, which is KDS, started at 8:30. Then the other one is starting at 9. This means that before the KBL began its journey, KDS has already traveled for half an hour. So half an hour at a speed of KDS 80 is 40 kilometers. So the relative distance by the time the two vehicles will be both moving, relative distance shall be 460 minus 40, giving us 420 kilometers. So the distance between them at 9 a.m. exactly is 420, because the bus which is from Alliance High has already begun its journey 30 minutes earlier, so it has covered 40. By the time KBL is starting from Maseno School, KDS from Alliance has already covered 40 kilometers. Therefore, the distance between them at 9 is 420. It is 420 to be covered at the speed of 140 now. Therefore, the time taken, which I would call the relative time, is the speed over the distance between them over the speed that they are covering it at 140. So when I take 420 and I divide by 140, I'm getting exactly 3 hours. So it is 3 hours for them to meet. 3 hours for them to meet. So determine the time that they will meet. From 9, when we add 3 hours, this shall be 12:00 noon, or 12:00 hours in the 24-hour clock system. So this is 12-hour clock system, 24-hour clock system. You express in any of the formats and you shall be correct. That will. So that's how we work out that particular question. It is good we look at number 23 now. It's very advisable for us to look at number 23. The equation of a curve is y equals to 2/3 x power 3 minus 1/3 x squared minus 2x minus 1/5. Find the y-intercept of the curve. We know that very well as we discussed about equations of straight line, that at the y-intercept, x equals to 0. At y-intercept, the values of x are 0. So what is the value of y? 2/3 x is 0 squared, power 3 actually, 1/3 x squared 2x. So we're getting y equals to negative 1/5. That is the y-intercept for this particular curve. Part 2 of the equation, what does it talk about? The equation of the normal to the curve at x equals to 0. At x equals to 0, we're supposed to write it as a coordinate first. Because when x is 0, as we have just worked out, the value of y is negative 1/5. Therefore, the coordinate that we need to work is We need the normal at this point now. 0, -1/5. That is the coordinate which we shall be working with. So we're supposed to say this, that we need the gradient function of this particular curve. What is the gradient function of the particular curve? Gradient function shall be the differentiated function, dy dx, the differential. We differentiate dy dx to get gradient function. So to differentiate this polynomial, the first term will give us, we drop the power, it's power 3, so we multiply the constant with 3. 2/3 by 3 now shall give us, 2/3 by 3 shall give us 2. Then now, x, which was to power 3, now becomes squared. We proceed to the next term, which is a third. We also drop power 2, so that -1/3 multiplies by 2. So it will be -2/3. X, which was power 2, now becomes power 1. Then x is automatically power 1. So we drop 1, -2 by 1. It is just the way it is. It makes -2. Then x, which was to power 1, now becomes power 0. X power 0 is just 1. Anything power 0 is 1. So we've now differentiated the function. So what is the gradient at x equals to 0? Gradient of curve at x equals to 0. It shall be 2, 0 power 2, 2/3, 0 minus 2. This is -2. So we have a gradient of -2. The gradient for this curve, imagine it is gradient of the curve at point x equals to 0. The value of the gradient is a -2. If the value of the gradient is -2, then we can talk about the value of the gradient of the normal. Remember, the normal is perpendicular to a tangent at that particular point. So gradient of curve is also equal to gradient of tangent. But now a normal becomes perpendicular. A normal is a perpendicular line to the tangent at this particular point. If the curve is passing this way, and we have point 0, -1/5, we are saying that a tangent here is the one to have a gradient of -2. The tangent at that particular point will usually have a gradient equivalent to the gradient of the curve at that particular point. But now we are talking of a normal line. A normal is a line perpendicular to this one. So the gradient 2 of a normal shall be half. And this tangent now is passing through 0, -1/5. So this is together with xy for us to get the equation. Together with xy for us to get the equation. Yeah, for us to get the equation well. So now with that, you're supposed to know that the equation of the tangent of the normal can now be expressed. We talk about half, the gradient, change in y minus -1/5 over change in x minus a 0. So cross multiply 2y, minus -1/5 becomes plus 1/5. So plus 2/5 equals to x that way. 2y, let me work it out very keenly. 2y equals to x minus 2/5. Then we divide by 2 through. Y equals to half the value of x minus 1/5. I'm subtracting 1/5 because I'm dividing by 2. Everything divided by 2 or through. So this is now the equation, ladies and gentlemen, that we wanted. There is another part of this question, that is a part B. Determine the coordinates of the turning points of the curve. Determine the coordinates of the turning points of the curve. Turning point is a point where the gradient of this curve becomes zero. We also call them the stationary points of the curves. So we can say at the turning points, at the turning points, gradient, which is dy dx, becomes at the turning point. So the gradient function is already here. So 2x squared minus 2/3 x minus 2 equals to 0. That is what you mean by gradient becoming 0. So we can get the values of x when gradient is 0. When gradient is 0. Solving this equation can involve even the quadratic formula or the completing square method or the factorization method. Let's multiply by 3. Though I can see 2 is uniform, x squared minus, when we divide by 2 throughout, this becomes a third. X plus 1 equals to 0. Then we can talk about completing the square. To remain with x squared minus a third x, we're supposed to add a constant here and 1 taken to the right, and we also add a constant. This constant should be added to ensure that the left hand side is a perfect square. So this constant should be b over 2 squared. So this constant will be negative a third, divide by 2, then we square. So this is going to be 1 over 6 squared, which is 1 over 36. So we add it on both sides, 1 over 36, that way. So we can factorize the left hand side. This shall be x. To factorize this, we need to take the square root of this, the sign that follows, then the square root of this part, which is 1 over 6 squared equals 2. So I take 1 plus 1 over 36. So I'm getting 1 and 1 over 36. That way, yeah. 1 and 1 over 36. So from this, we can take square root of both sides. Now, the square root of both sides, ladies and gentlemen, the square root of both sides shall give us x minus 1 over 6 equals to square root of this part, which is 1.0148. Let me use 4 decimal points that way. So what are the values of x? The first value of x shall be when I add 1 over 6 to this, and I'm getting 1.1805. Then another possible value of x shall be, I take, the square root of this positive part, the square root of the constant on my right should be plus or minus. So there is another option of getting minus 1.0148, and I add 1 over 6. So I'm getting negative 0.8481. That way. Negative 0.8481. With these values of x, we can now talk about the corresponding values of y. Remember, we need turning points. These are coordinates. So we have the x values at the turning points. So when x equals to 1.1805, the value of y shall be Now we substitute in the original equation that gives us y. Remember, the original equation is, the original function is y equals to 2/3 x power 3 minus, we can write it, let me just get back. Yeah, 2/3 x power 3 negative a third x squared, a third x squared negative 2x, then minus a fifth, that way. So when x equals to 1 point, what is the value of y? We just substitute to get the value of y in that particular equation, and we all can substitute. Ladies and gentlemen, we all can substitute. So let me substitute. 2/3, the value of y is 1.1805. This one I cube, then minus a third, I open brackets again, 1.1805. This one I square, minus 2 into y, so 1.1805, and minus 1/5 finally. So this is giving me negative 1.9288 that way. Yeah, 1288. Actually, as a coordinate, as of a turning point, we can have it as 1.2 negative 1.9 that way. For plotting purposes, if we were to plot this, you can't plot all these significant figures. Then at x equals to negative 0 point, the second value, 8481, the value of y shall be, we substitute again, the value of y when x is the alternative. So y over 2/3 into negative 0.8481 cubed, over 3 negative 0.8481 power 3 minus a third into negative 0.8481 squared minus 2 into negative 0.8481, then minus 1/5 that way. I hope I'm substituting very well. This one should be redone, sorry. Let me just retype it. 2/3, and I hope you're doing the same, 0.8481 minus a third into negative 0.8481 squared minus 2 into negative 0.8481 that way, then minus 1/5. Yeah, I'm getting 0.6910, which means this as a coordinate now shall be negative 0.80.7. So we have the two coordinates now. These are the turning points for this particular curve. These are the turning points of the particular curve. Number 24, ladies and gentlemen, we are talking about a certain question here, which is on vector 1. A very good question. We can go through the question together. Let's remember that consultation line. You can also acquire revision materials from our platform using this particular line. So please reach out to our WhatsApp. You can also consult about our revision programs through the same line. The position vectors of P and Q are -5, and 10. These are position vectors, which means that the coordinates again of P and Q respectively, because these position vectors are with reference to the origin, then P is -5, 10, and Q is 2, -8. This is positive, sorry. Point A is the mid of PQ, and point B is on OP such that 5 OB equals to 2 OP. All right. Find part 1, the vector PQ. For us to get the vector PQ, we need to take Q minus P positions. So Q is 2, -8. We subtract -5, 10. This now gives us 7, -18. That is the position vector, or the vector, the vector PQ. That is it. We can express it as a column vector, no problem. Then look at part 2 of this. We find the coordinates of points A and B. Where is A? The midpoint of the midpoint of PQ. If it is the midpoint of PQ, sorry, and we have the coordinates, the midpoints of PQ, and we have the coordinates of P and Q, then we need to talk about the midpoint being equal to -5 plus 2, and we divide by 2. Then y and the other y also divide by 2. So for us to get midpoint, generally, it's usually given by 1x and the other x over 2, this is x2. Then 1y, y1 plus y2 also over 2. That way. That's why I'm getting -5 and 2 divided by 2, then 10 and -8 also divided by 2. So the coordinates of A now shall be, this is -3 over 2, which is -1.5. Then 10 plus -8 becomes 2 over 2, which is 1. So this is the coordinate of A. What about the coordinate of B? We are given further instructions that 5OB equals to 2OP. Let's talk about OB being equal to 2 over 5OP. So OB shall be 2 over 5. The value of OP is -5, 10. So this shall be 2 over 5 by -5, giving us -1. 2 over 5 by 10, giving us 4. Is that 4? Yeah, 20 over 5. And also, -10 over 5 should give us -2, not -1. -2, that way. So the coordinates of B is -2, 4. -2, 4. That way. Let's look at part B. Find the magnitude of AB. For us to get the magnitude of AB, we should get AB first. Remember, we need B minus A. So vector AB shall be this -2, 4 minus -1.5, 1. That way. So the vector itself is a -2 plus 1.5 becomes -0.5. Then 4 minus 1 becomes 3. That way. So the magnitude of AB shall be, when we take -0.5, we square, plus 3, we also square. Then we take the square root. So 0.5 squared plus 3 squared, now the square root. So we need the square root of 81.25 units. This is, you take the square root now, 9, and wait. 3 squared is 9 point something. I don't think I've calculated that one well. 0.5 squared plus 3 squared is 9.25. Sorry, that should be a mistake in my typing on the calculator. So I'm taking the square root of 9.25. So when I carry out the square root now, it means the units are 3.0414 units. Yeah, 0414 units. That is now the answer. Yeah, that is the answer. That is cool. That is quite cool. Part B. Part B. Remember, we are winding up, ladies and gentlemen. We're just winding up. So you don't need to worry. You don't need to be worried. At this point now, I'm having the magnitude of a point C, which is negative. Okay, the coordinates of point C, which is negative 3m. Vector CP and OQ are parallel. Determine the value of M. Vector CP. Let's get vector CP first. Where is P? Here. CP means P minus C. So negative 5, 10. Negative 5, 10. And negative 3m. That way. This gives us a negative 2. Because of negative 5 and a positive 3, this gives us 10 minus m that way. That is the vector CP. Then the other vector is OQ. The vector OQ should be known. Vector OQ is 2, negative 8. OQ equals to 2, negative 8. Now we are told that these two vectors are parallel. That means there is a scalar multiple of one vector that should give us the other vector. There is a scalar multiple of one vector that should give us the other vector. So CP equals to a certain scalar multiple of OQ. So CP is negative 2, 10 minus m to give us 2, negative 8 by a constant. So from the y, from the x components, we can get the constant. So what is k? Negative 1. So with k as negative 1, it means the same k should multiply the y components. The same constant should multiply the y components. Let's get that. So we should say that 10 minus m equals to negative 8 times a negative 1. You know, this will give us 10 minus m equals to positive 8. How do we get m positive? 10 minus 8, which is 2. So the value of m is a 2. And finally, we are talking about translation vector. A translation T maps P, negative 5, 10 onto P prime, negative 2, 10. Determine the translation vector T. A translation vector plus an object should give us the image. Therefore, the XY translation vector known plus negative 5, 10 is supposed to give us negative 2, 10. So what is this translation vector? To remain with x, we need negative 2 plus 5, which is a 3. To remain with y, we need 10 minus 10, which is a 0. So the translation vector is 3, 0. 3, 0. That is the translation vector which was involved. Remember, this is the last question. We are done with the section 2 of this great paper. Thank you so much for following. Remember to enroll to our August programs. Otherwise, thank you so much.